Hello everyone, thank you for being here. So this was the announced panel in the previous session. We have here 4 fantastic panelists to discuss about the past, the present, and the future of heat reuse. It sounds fantastic as a title, and you'll see why afterwards. So we have totally different profiles, even someone who's not from the industry, which is something unusual in these conferences. And we are very pleased to have her here. So I showed this slide before. It's just a short introduction of what we're doing, where you can find information about the project. We have regular calls. Please join our calls. Bring your experience on the table. Maybe you want to learn something, join as well. A couple of people gathering there, having nice discussions. Yeah, sometimes funny discussions as well, not only serious stuff. And yeah, so this panel hopefully will bring some light also on some challenges and future topics about heat reuse. So I'll just introduce you very, very briefly, because we all have not much time for discussing. I also want maybe to give some time for questions from the audience. So we have Jakob Bergstedt, who's head of operations of Conapto, a Swedish colocation company, data center colocation company. We have Pauline, policy director of Euroheat and Power, which is the association of district heating and district cooling companies in Europe. We have John Summers, who's a scientific leader in data centers from RISE, so Research Institute from Sweden. And we have Drew Turner, so global head of business integration at Danfoss. And myself, I'm Jaime Comella. I'm calling the heat reuse sub-project, and I work at AQ Compute. I will put on the background, Pauline, you asked to have a slide with some data. So feel free to ask if you want it. I have it here. And well, just let's start. So the first question is, we are not seeing a lot of projects for heat reuse. I mean, we are talking a lot. We want to make this possible and more common. We're still not seeing a lot of them. I mean, we have a map. We only have, 80, 85, 90 projects there mapped. And there are definitely many more projects being built around the world. I mean, alone, some hyperscalers are building hundreds of them. So why do you think this is happening? And especially this question for John and Jakob. You have some experience already with heat reuse in different sizes and different modalities, right? What do you think this is happening? And can you tell success stories, failure stories? Please, John.
Micro. So we have to pass the mic here. So yes, it's John Summers. So my take on the past really is probably that there are some small examples of this happening, and I think Jakob will explain what they're up to. What we were looking at in a project that was actually looking at on-site power generation and using that as a co-generation in the loop with some liquid cooling to try and raise the temperature for district heating. So, you know, on-site power generation maybe is an interesting way of doing this. I think we're still challenged by temperatures, even at the liquid cooling phase for a lot of networks. And of course, there's a lot of debate about whether we should be feeding straight into district heating networks that are running at high temperature, because it doesn't really match. I mean, the future really about that is really whether the talk about temperatures of CPUs going down and so going the wrong way. Everything's going the wrong way. We're always challenged by physics, but that's the great thing about engineering. It's always about compromises. So I think we need to. But I can talk more about the project. I don't know how much time I have here really to talk about it, but the idea was using fuel cells in the loop, and we were using locally produced biogas, so that's taking organic waste, wastewater, and I noticed on the slide that wastewater is actually one of the uses for heat recovery. But the bio, you know, obviously if the methane is not emitted to the environment, if you put it through our energy system, then we still have CO2. It's not carbon zero. It's not zero carbon, but at least we can upgrade the heat through that without the use of a heat pump, you know. But traditionally, this is probably for heating networks. It's the heat pump that's in the loop, and I don't know whether it's a point to take it now about the metrics for that, or whether I should take it later. Can I do it now? Yeah. So yeah. So maybe it's so. There are some metrics that the data center, that the EU wants to collect lots of data and present these metrics For what reason, I'm not sure, but that's still to be figured out. But I know they want to, and you can't really compare data centers based on PUE, but what we do know is that the metrics are not fit for purpose, I think, because if you have the heat pump in the data center, then that affects your PUE. But it also helps what's called your energy reuse factor. So the PUE is the power usage effectiveness, because it's energy that you're consuming to run the heat pumps. If you've got the heat pumps in the district heating network, then you are rejecting your heat to the district heating, but you are receiving chilled water back. And the PUE calculation should take into account the water you're getting back. So, but I don't think that's, and I've talked to people who are on the ISO standards, and they tell me that yes, there's a problem with this. I don't sit on the ISOs, the metrics that for the PUE and the ERF. And so I think that's going to be addressed, because then it makes it a little bit more of a level playing field. And I'm sure Jakob may have something to say about that.
Well, yeah, thanks. So I guess from my side in heat reuse, it's all about location, right? And finding opportunities and hopefully cities where you have a large district heating network or some other taker that can, you know, receive the heat that you are emitting anyway. And for us being based in Stockholm, that's a good opportunity. Not sure if you're aware, but we're talking 3,000 to 4,000 kilometers of district heating network already in the ground. And for us, if I take the North Campus we have as an example, we're in a municipality where they have more consumption than production in the district heating system. So there was an opportunity there where we were a large consumer of electricity, of course, but also a potential heat source. So with collaboration with the local authorities and of course the local utility, we've been able to be seen as a heating plant, basically, that is an outpost in the municipality and provide heat to homes, etc. That are live operational. And speaking of the ERF PUE discussion, of course, yes, we are providing heat pumps to upgrade the heat because it needs to be able to be used, and that has an effect on our PUE, running on the PUE. And running heat pumps, we're arriving at about 1.5 in the PUE, so still quite low compared to other locations in the world. Without the heat pumps, we're about 115, 125, depending on the site. But then again, if I would not have the heat pumps and I would just give away the low-grade heat, then, as Jan said, then I would have free cooling provided, and I need to take that into account as well. So yes, we have some kind of discrepancy there. I agree.
And Jakob, you mentioned in a discussion before that one of your data centers is providing almost 90% of excess heat?
Yes, exactly. And that's one of the greatest opportunities that we had in the North Campus, that where the consumption was higher than the production in that municipality, they have a need year-round. So even if it's 20, 25 degrees outside, they still need to provide district heating to people showering, or they need hot water to wash their hands. So we have an ability to deliver year-round and save on the energy usage that would otherwise be on the chillers or providing cooling there. And that gives us, a reuse effectiveness, or ERF number of just above 90%, or 0.9.
Thank you very much. So we see actually incorporating utilities in a very early stage, and so to create this project is actually beneficial, right? So actually, there's still some barriers of intersectoral coupling, right? I'm looking into the other two panelists. Since we have somebody from another sector, and it's probably the biggest candidate to get that heat away from data centers. So what needs to be done? What has been done also so far for this intersectoral communication? Is there enough? This is improvable? Pauline, please.
Thanks, Jaime. Hello, everyone. So maybe just to put things in their context and why I'm here, and I'm super happy finally to meet the peers from your sector. There is a momentum for waste heat recovery from data center. I think we've been, as district heating, talking about it for a long time. Even we have some concrete projects, but there is a push for this. From the legislation, from the geopolitical context, we are a sector that still needs to decarbonize 60% of our mix, and we are looking at waste heat from data centers. So that's why we are discussing, and this is the first step. We are two different sectors. Our specialty is to produce heating and cooling, and your specialty is to process data, if I say that correctly, more or less. So you're not energy producers. So I think the first step towards being able to harness this big potential, and there are a lot of studies already, and I brought you some data from the reuse heat projects. That's an EU-funded project, and it's not the only one, but that's quite a foundation. But we also have a study with the Aalborg University in Denmark that has identified a potential for new sources for district heating of more than 221 terawatt-hour a year. So it's substantial, and that added to the other decarbonized heat sources will contribute to the decarbonization of our sector. So obviously, we need more of this project to identify the potential. I think this is being done, but another aspect that we still need to figure out by also talking to each other and by industry-led kind of initiative is the business model. And I think my peers here on the panel will complement what I say, but this is not obvious. There are many projects and maybe as many different kind of business arrangements, and one of the big questions is what is the value of this heat for all the partners involved, and what is the arrangement? Who is paying for what? We've heard that sometimes we need a heat pump. Who is paying for this heat pump? Where is it installed? Who has access to what? So these are some of the key questions that we need to discuss together. I think that would be a good intro.
Find also some maybe standard contracts and so on between the different parties. I mean, I know there is no standard project for heat reuse still, but maybe we can help on that, right?
Yeah, of course. A few years ago, we started to talk to our peers from other associations, including EUDCA, the Data Center Association. We are both based in Brussels, and I think now we're converging towards the need to have this kind of relationship standardized, because we know that this project actually takes too much time, and we are under pressure politically and under the climate change pressure. So we need to make this happen, not in 10 years, but now, and to get all these projects started. So such standard or template contract could help accelerate the negotiations and enable not to reinvent the wheel every single time for every single project.
Yep.
So we will be working on that as cross-industry initiatives, and also together with OCP and all of the interested partners.
Drew, about the technological barriers for intersectoral coupling, Net Zero Innovation Hub, that you are one of the most important parts probably of this. What is your opinion on this?
The technology barriers, as Pauline highlighted, are much lower than the business barriers. The good news is, from the technology side, everybody's moving in the same direction, somewhat independent of the Net Zero Innovation Hub. I think the Net Zero Innovation Hub is just going to solidify for hyperscalers, big data centers in general, the direction that they're moving in general, which is to enable heat reuse and to give it away for free, right? And do it because of the motivation of the ability to get free cooling and to remove barriers to building new data centers. We see that based on multiple different customers that we're working with moving in that same direction now. So the technology barriers are not near as much of an issue as the reuse barriers and primarily business barriers on the off-taker side. That is the number one thing. Because the other thing that happened is that all of these companies that are working in the same direction also created a business model around the heat reuse side. And I think every single one of them has now eliminated that because they figured out that it was so tough to do. That is the biggest barrier, is you have a business that is focused on data management and you have a business that is focused on energy, distributing energy to customers, in the case of district energy companies, and bringing those two together and matching up the business model for them through the technology system design, which is all moving in that direction of the heat recovery station built into the data center and then the heat pumps somewhere downstream of that. That's the easy part. But the business barriers and enabling the contract and getting everybody, instead of 3 people on a commercial project nodding their head on a sector coupling project, it's more like 20 people nodding their head at the same time. That is the number one thing.
Thanks, Drew. So, meaning that probably policies are going to be needed on this. And I was looking to Jakob and Pauline. Actually, in Sweden, there are not big policies contributing to this, but you have done this. I mean, you have this is one of the best examples in the world, the Stockholm area and the data parks we were talking before. Yes, do you think policies will push us farther? I mean, how important they are? I mean,
well, yeah, I think policies will definitely help us, actually coming over the edge to actually do it. But I think the other side is also, okay, we are enforcing maybe the data centers to give away the waste heat. But who is the taker, and is the taker there, and where does the responsibility end? So I think that's an important question to ask as well. Yes, I think we all can, with small changes everywhere you are in the world, say I am ready to do heat reuse because I can give away my cold or my hot return from the computer rooms, right? But going forward from that, I think, yes, policies might help, but it's, eventually so that you need to think of the other values for you as a company as well. Are you a big user, or can you contribute in other ways? Reuse the heat or grid services or anything like that. So yes, but not only.
And what's in a number? You see the German law asking for 10%, 30% of heat reuse. Are these realistic numbers? Well, in your case, you say yes.
For my case, yes, because I'm doing 90% in one of the sites, and where I am able to deliver all year round, right? And that's another important factor. In many cases in the world, that won't be possible in the district heating network. So you'll have to find another player to receive the heat.
So it's all about location, more or less, right?
Yes, I believe so, yeah.
And Pauline, then for finding the right location, we might need some tools, some platforms. I mean, you think this matchmaking platform is something that will be crucial for this?
Yeah, maybe if I can,
yes,
I'll
please.
get back to that. But I think policy is super important. That's my whole job, so I won't say anything else. But I think we also have primarily also, it seems to me when I talk to data center people, that there is a public perception to address that we're both polluting sectors, and so this is the sort of starting point. I think what drives the heat recovery, and also in Sweden, is that they have a tax on carbon. So that's a powerful driver to basically be pushed out of the use of fossil fuels. And I think this is what's happening and why there is this momentum, because we realize that we really need to get out of the use of fossil fuels. So looking at alternative sources. Now we have a huge package of legislation that has just been adopted. It's called Fit for 55. It's all about climate targets. And we have powerful tool here, like to drive the waste heat recovery, in general, the decarbonization of the heating and cooling sector. Because we don't always realize it's more than 50% of the total energy consumption, so that's absolutely huge. And that's in the residential sector, industrial sector, and we're not even talking about very high temperatures. So it's for your hot water, it's for pharma industry or food industry, so it's not super high temperature. So, and we have good measures that are coming. Maybe just to mention two of them. Of course, it's all based on the recognition of waste heat, including from data center, its complementarity to renewable energies in the decarbonization process. So, but based on that, we will have, as it's the case in Germany already, heating and cooling plants that will be obligatory for municipalities above 45,000 inhabitants to prepare. So that will tremendously help, like, to identify what are these decarbonized heat sources and how to match them to the demand. And so this should also push the rollout of district heating or any kind of network to use the heat. Because, well, if we identify the sources, then we will have to build the infrastructure, so that will help, and that will bridge this gap of the distance or, well, the fact that you need a network to collect this heat and harness it. And then the second is more related to our sector. We have clear, and it's the case also for your sector, we have clear targets, carbon neutrality by 2050. Data center is even more ambitious, by 2040, I believe. So this will also drive, and there are several milestones where you have to increase your renewable energy and waste it into the district heating mix. So this will be definitely something that will push the recovery of waste heat. And then in terms of platform to support this heating and cooling plan, obviously it will be key to have things that will enable to quickly support municipality to identify the various heat sources, and this matchmaking platform could definitely help. And I'm not exactly sure of the number of cities in the EU that are above 45,000, but that should already be a substantial number. So if all of them are already making these plans, that should be helpful.
Thanks, Pauline. And now let's just talk about the elephant in the room, which is the temperature problem of the chips. I mean, someone asked something about this, I think in the past session. In another session, I think yesterday, with a similar question was asked. So we're seeing that inlet temperatures to hardware are going down, and I'm looking to John directly. So I think you can elaborate on that. I mean, what do you think? What is your opinion? I mean, where are we heading to? And is physics going to beat us in this game?
It's a little bit confusing, isn't it? Because there are different factors at play here. But I mean, I can go by some examples. So I don't know if anybody has visited the data center in Kajani, which is the LUMI, which is the European high-performance data center. They reuse the heat from their system. They have, I think it's 3 heat pumps underneath the data center. The data center is on the upper floor. And they are using direct-to-chip solutions. It's an HPE solution, Cray HPE, and they've got GPUs in the loop and they've got CPUs in the loop. And everything throttles when that temperature is higher than 32 supply. They get 44 back, and then they have to upgrade to 85, and that's why the heat pumps are there. So I think the white writing is on the wall with these high-end systems that if you use, even if you're using direct-to-chip, I mean, it's a particular type of direct-to-chip, and we know that there's a myriad of different ways of doing direct-to-chip, as there is doing other solutions like immersion. So I think we need to understand what's happening with IT. Why is this happening? And I think there are different debates about this. One of the things that is that we are trying to light up more of the transistors on the dies. So traditionally, if you do the back of the envelope calculations, that it's rated at, say, 700 watts TDP, like the H100, but if you do a back of the envelope calculation based on the number of transistors, the dissipation per transistor, and the speed at which it's switching, it should be pulling 1.3 kilowatts. So part of that silicon is dead, is off at any one point in time. But as we move, trying to move and get more compute out of it, we are generating a problem. And of course, the memory is now stacked. I mean, it was mentioned, I think, in Steve Mills' presentation about this, that the vias are stacked, and so it's very difficult to get the heat away going 3D. You know, maybe you need to pass the coolant through the, and it's really challenging. So I don't know where this is going to go, but definitely the indication is for high-end stuff now that they require a lower temperature, unless you want to throttle, unless you want less compute, which is another thing we can consider. You know, when we need the heat, we throttle the compute and run hotter. I mean, there are things that we can do, yeah. I mean, it's an engineering system at the end of the day. We have to ask these hard questions, and it's a compromise, yeah, all the time.
Like conditioning the design of hardware in order to boost the temperature, right?
Yeah.
For another debate, maybe.
It's a further debate.
We need somebody from
but
the
I
OEMs,
think,
chip manufacturers here.
Yeah, I mean, the point is always that, you know, why do you build data centers is for the IT. I think we should always focus on what happens with the IT. Because if you look at the history of this industry, we've been caught out when something changes, a paradigm shift. Maybe there is a paradigm shift coming along, but I don't know, you know, it's very difficult to get that crystal ball going and give us the right answer.
Drew, your experience about capturing excess heat, whatever, in different sectors. So what's your opinion about this changing scenario, about different temperatures, different kind of hardwares? What is your approach to this? Do we always need to boost it, always heat pumps?
Yeah. So what our team does, right? We're a social experiment within Danfoss Danfoss getting into the system solutions design business. And then all of the systems, integrated large-scale energy systems that we design, every conversation we have, we baseline with the experience of the others, right? And when you do that, you talk about the experience of the systems that you've designed, and you talk about data centers specifically, and the trends, we were just talking about this too. 25 years ago, they were cooling at 7 degrees C, like comfort cooling temperatures. And then they figured out, okay, well, it's a sensible load, and then they increased it to 15. And they figured out, okay, well, it really doesn't need to be 15. It could be more like 20. And then you get direct on chip, which pushes it to 30 plus, and then you get submerged servers, which everybody's moving in that direction because of AI and processing speed and heat generated. And that baseline tells you that everything has gone up in the past, and maybe it will go down in the future because of the density and the chip demand, and you don't have that next move to push it back up again. But from what we've seen from the previous experience, it's all moving up. And every 1K that it moves up on the off-taker side, that increases their business case by 2%, with a corresponding cost reduction of 2%, with a corresponding electrical infrastructure reduction of 2% to reuse that heat. And the baseline that they're comparing that to, most of them, is utilizing an air-to-water heat pump as their primary source. And your starting point is at least 40%, even with that 20C historic chilled water system design temperature. Your business case is so much significantly higher, and everything that we see is moving in the positive direction. That's why we say, as a summary, when we talk about this, that from our perspective, critical facility cooling systems, whether it's a data center, an industrial process, a wastewater facility, anything that has a backup power system, which is another longer part of the story, is the future baseload energy supply for a decarbonated district energy system. And that's the story that we tell, but it's all tied back to that baseline of the history of data centers and then the history and experience of designing these systems.
Thank you very much. Well, now we have still a couple of minutes. If someone wants to ask something, perfect, of course. Just say your name and affiliation.
Herb Zion, Liquid Cool Solutions. Interesting conversation. The matchmaking portion of this is important because it becomes increasingly clear that this is a site-specific situation. I mean, your 90% is very unusual. And in the ideal case, just by way of background, and a friend started what became the largest owner of district energy systems in the US, which we sold. And that model probably doesn't work anymore. It's a bad method. It's generally a bad platform for for waste heat recovery from data centers because it's a seasonal load and the temperatures really don't match. But there are multiple cases out there for hot water heating, industrial preheating, all kinds of specific situations where matchmaking could really be a valuable service in order to connect the buyer and the seller. I mean, there is no business model that I can see, based on my own experience, for matching district energy with waste heat recovery in general.
Thanks, Herb. I don't know if you want to answer that.
Thanks, Herb. Yeah, I think it's a collaboration, and then that's why we're here, isn't it? In an open compute project, it's all about collaboration. I mean, that's what the strapline says. The data centers can't do this on their own, so we need to find symbiotic relationships. That's my view on it. And we shouldn't ask data centers to manage heat anyway. They need to do other things.
Thanks. Next question.
So Rodney, again from Main Cubes. If you could go back to the last slide you had up, I just wanted to understand, or if there's a clarification possibly. So out of the 997 data centers, 28 are located within 2 kilometers. Are those 28 the ones generating the 270 petajoules, or are there others amongst those that are generating possibly less? Just a bit of clarification on the phrase. Thank you.
Just making some sports here.
Yeah, I'm not fully sure. I would have to get back to the project, but it's EU 28, so it's the 997 data center within 2 kilometers. But I'm not sure that this mapping is addressing specifically the heat produced by this 997. EU 28 is the EU 28 is the 27 member of the European Union plus Great Britain. Sorry.
It's a grammar problem, yeah.
Yeah.
It's a grammatical error.
I know we have much time for questions. I think the next session is there. So thank you very much. Thank you, the panelists. And, well, big applause.